Through the salt-crusted lenses of Japanese field binoculars, the Pacific atoll looked exactly as it should, a barren white scar of dead coral stretching flat against turquoise water. Lieutenant Commander Tokishi Yamamoto lowered the glasses slowly, his hand trembling, not from fear, but from something far more unsettling. Disbelief. 3 days ago, this reef was empty. A geological fact. A strategic void. The kind of place you marked on aviation charts with a single notation, unsuitable for aircraft operations. Now, American fighters sat on it like steel insects, their propellers catching the morning sun. You cannot put planes on coral, Yamamoto whispered to his adjutant, more to himself than anyone else. It wasn't a tactical assessment. It was a law of nature. Coral crumbled under weight. It shifted with tides. It absorbed water like a sponge and baked into dust under tropical sun. Every engineering manual published by the Imperial Navy said the same thing: coral atolls were aviation dead zones. Protected not by guns, but by geology itself. And yet, there they were. What Yamamoto didn't know, what couldn't know, was that the Americans hadn't tried to defeat the coral. They had turned it into a weapon. The very reef that should have stopped warplanes had been crushed, rolled, and compacted into a surface harder than the concrete runways back in California. Nature wasn't a shield for these islands. It was raw material. And America had brought the factory to the front lines. This is the story of an engineering miracle so radical, so improvisational, that it broke the logic of modern warfare. It's the story of how coral, dead, brittle, impossible coral, became the foundation of American airpower across the Pacific. And how a ragtag army of construction workers with bulldozers and bourbon rewrote the rules of what was possible in war. The Japanese never saw it coming. Because it shouldn't have been possible at all. In the war rooms of Tokyo, the maps told a comfortable story. Across the vast blue emptiness of the Central Pacific, tiny coral atolls dotted the shipping lanes like scattered rice grains. Each one was marked with careful notation: reef depth, tide cycles, soil composition. And in the margins of nearly every chart, the same verdict appeared in neat kanji: unsuitable for air-base construction. This wasn't wishful thinking. It was engineering orthodoxy. Japanese military planners had studied these atolls for decades. Their surveyors had walked the reefs. Their engineers had tested the substrate. The conclusion was unanimous: coral could not support aviation infrastructure. Not without massive imports of concrete, steel, and heavy machinery, supply chains that would take months to establish and weeks to deliver. Any American attempt to build airfields on these remote specks of limestone would require the kind of logistical miracle that simply didn't exist in wartime. The math was clear. To create a functional runway, you needed a stable foundation at least 18 inches deep, capable of withstanding the impact of multi-ton bombers landing at 100 miles per hour. Coral, in its natural state, was porous and brittle. Under pressure, it shattered. Under moisture, it dissolved. Under the weight of a single truck, it cracked like eggshell. Even if the Americans somehow managed to pulverize the coral into gravel, they'd still need binding agents, cement, asphalt, tar, and materials that had to be shipped from industrial centers thousands of miles away. The Imperial General Staff estimated a minimum of 6 months to establish even a crude forward airstrip on a contested atoll. 6 months of naval protection. 6 months of vulnerability. 6 months during which Japanese air and submarine forces could strangle the project in its infancy. So when intelligence reports began filtering back in late 1943, describing American aircraft operating from islands that had been empty reefs just days earlier, the initial reaction wasn't alarm. It was dismissal. The reports had to be wrong. Or exaggerated. Or misidentified. Perhaps the Americans were using seaplane tenders, floating operations, temporary anchorages. Because the alternative, that the United States had somehow solved an engineering problem the entire Imperial Navy considered unsolvable, was simply too disruptive to accept. It would mean every defensive calculation, every fortified perimeter, every strategic buffer zone was built on a false assumption. That the ocean itself was no longer a barrier. That assumption was about to cost them the war. They weren't supposed to be soldiers. That was the first thing you noticed about them: the way they stood, the way they talked, the way they held their rifles like borrowed tools instead of extensions of their bodies. They were welders who'd spent 20 years in Pittsburgh shipyards. Dynamite men from Montana copper mines. Crane operators from San Francisco docks. Bridge builders, road pavers, lumber mill foremen, and utility linemen who'd been installing power grids across rural America since before the Depression. When the Navy formed the construction battalions, quickly shortened to the phonetic Seabees, in early 1942, they didn't want academy graduates or parade ground soldiers. They wanted men who knew how to make things work when the manual was wrong. Men who could look at a broken bulldozer, a pile of scrap metal, and a bottle of whiskey, and somehow have the machine running again by sunrise. The average age was 37. Ancient by infantry standards. But the Navy didn't need teenagers who could march in formation. They needed professionals who could improvise under fire. And improvisation was their native language. Take Chief Petty Officer Frank Hammer Irons, a former Kansas highway contractor who'd paved half the roads between Topeka and Wichita. When his battalion landed on a nameless coral atoll in the Marshall Islands, the engineering survey concluded the reef was too soft for heavy equipment. Standard protocol called for waiting on steel matting from Hawaii, a delay of at least 3 weeks. Irons looked at the coral, looked at his equipment manifest, and said 6 words that became Seabee doctrine: "We'll figure it out right here." Within hours, his crew had stripped the oil drums off a damaged supply ship, welded them into a makeshift roller twice the weight of anything in the equipment manual, and begun compacting the reef in layers. When the coral dust wouldn't bind properly, they mixed it with seawater and crushed volcanic rock scavenged from a neighboring island. When the makeshift asphalt started cracking under the tropical sun, they added used motor oil drained from their own trucks. It shouldn't have worked. Every engineering textbook said it couldn't work. 72 hours later, a Marine Corsair landed on it. This was the Seabee method: ignore the rulebook, trust your hands, and build the impossible before anyone had time to tell you it couldn't be done. They worked in 100-degree heat with Japanese snipers in the tree line. They mixed concrete during artillery barrages and poured asphalt while bombers circled overhead. They built roads through swamps using wrecked landing craft as fill material. They constructed bridges out of palm logs and bomber fuselages. They turned coral reefs into runways, mangrove swamps into harbors, and volcanic rock into hospital foundations. The Marines had a saying about them: the difficult we do immediately. The impossible takes a little longer. It wasn't bravado. It was a schedule. And across the Pacific, on 1,000 nameless islands, these middle-aged construction workers were about to rewrite the rules of modern warfare, one crushed coral reef at a time. The science was simple. The execution was back-breaking. Coral, in its natural state, is a limestone skeleton, brittle, porous, and about as stable as broken seashells. But limestone has a secret: when crushed into fine powder and compressed with enough force, it begins to behave like concrete. The calcium carbonate particles interlock. Air pockets collapse. The material transforms from a geological curiosity into a weight-bearing surface. The Seabees didn't discover this in a laboratory. They discovered it with bulldozers and desperation. The process began with demolition. Massive D-8 Caterpillar bulldozers, 20-ton machines that could rip through rock, crawled across the reef like mechanical dinosaurs, their blades scraping away the top layer of coral. Behind them came the explosives teams. Seabees would drill shallow holes into the harder coral heads, pack them with dynamite or TNT scavenged from naval ordnance, and blow the formations into rubble. The blasts echoed across the atoll like thunder, sending clouds of white dust billowing into the tropical air. Then came the crushing. Specialized machines called rock crushers, or, when those weren't available, improvised rollers made from welded oil drums filled with seawater, pulverized the coral chunks into gravel, then into sand, then into powder as fine as flour. This was the key: particle size. Too large, and the surface would crumble under load. Too fine, and it wouldn't drain. The Seabees learned through trial and error that a mix of sizes, from dust to pebbles, created the most stable matrix. Next, water. Not seawater, which corroded equipment and left salt deposits, but fresh water when they could get it, or carefully filtered seawater when they couldn't. The water was sprayed over the crushed coral in thin layers, just enough to activate the natural binding properties of the limestone without turning the whole mess into soup. Then came the compaction, the most brutal part of the process. Massive steel rollers, some weighing 15 tons, crawled back and forth over the wetted coral in endless passes. 8 passes. 10. 20. The coral powder compressed tighter with each run, expelling air, interlocking particles, transforming from dust into something solid. Under the Pacific sun, the surface baked. The calcium carbonate crystals fused. What had been brittle white rubble became a pavement harder than the highway irons had built back in Kansas. But coral alone wasn't always enough. When the surface needed extra strength, for heavy bomber operations or cargo planes, the Seabees added whatever they could find. Crushed volcanic rock from nearby islands became aggregate. Broken glass from supply crates became filler. Used motor oil, asphalt tar from ruptured fuel drums, even molasses from the mess hall, anything with binding properties got mixed into the matrix. The Japanese engineers in Tokyo would have called it insane. An abomination of proper construction methodology. But on a nameless atoll in the central Pacific, with Japanese Zero circling overhead and a Marine Air Wing inbound from Guadalcanal, proper methodology didn't matter. What mattered was that it worked. And in 72 hours, bombers were landing where nothing but ocean should have been. The Japanese came every night. Not in force, just enough to remind you they were out there. A Betty bomber circling high in the darkness, its engines a distant drone above the cloud layer. Every 10 minutes, a flare would ignite over the lagoon, bathing the construction site in sickly white light. Then the bombs would fall, not aimed, just drop blind toward the noise and the glow of the work lights below. The Seabees didn't stop working. Petty Officer Second Class Raymond Jacobs, a former ironworker from Detroit, described it in a letter home: "You learn to tell the difference between their engines and ours. When you hear that high-pitched whine, you count to 10. If nothing explodes, you keep shoveling. If something does explode, you wait 30 seconds for the shrapnel to stop raining, then you keep shoveling. The runway doesn't build itself. Time was the real enemy. Every island had a clock attached to it, and the deadline wasn't set by engineers, it was set by admirals plotting the next offensive. The airstrip at Tarawa had to be operational within 72 hours of the Marines securing the beachhead. Not 73. Not 75. 72. Because in 73 hours, American bombers needed to be striking Japanese positions 400 miles west, softening defenses for the next invasion. Miss that deadline, and men died. Simple math. So the Seabees worked through heat that turned the coral dust into choking fog. They worked through tropical storms that flooded the half-finished runways and washed away days of compaction. They worked through equipment breakdowns that should have halted operations, welding cracked bulldozer blades in the field, jury-rigging hydraulic lines with rubber tubing from life rafts, rebuilding engine blocks using parts scavenged from wrecked Japanese trucks. When the freshwater supply ran out on Kwajalein, they distilled seawater using improvised stills built from fuel drums and copper piping. When the food ran low, they ate cold rations and kept moving. When the malaria hit, and it always hit, they took their quinine tablets, worked until they collapsed from fever, slept for 4 hours in the mud, then got back on the bulldozer. Chief Irons lost 3 men during the construction of the Eniwetok airstrip. Not to enemy fire, to exhaustion. One had a heart attack behind the wheel of a grader. Another collapsed from heat stroke while hand-tamping coral around a drainage culvert. The third simply didn't wake up one morning, his body finally surrendering to weeks of 18-hour shifts under the equatorial sun. The runway opened on schedule. 71 hours after the first bulldozer hit the reef, a Navy F-6F Hellcat touched down on crushed coral, taxied to the end of the strip, and radioed back to the carrier: "Surface is solid. Recommend full air operations." The clock had been beaten. Barely. The raid on Maloelap Atoll was supposed to be routine. A reconnaissance sweep to confirm what intelligence already knew: the island was an empty reef, strategically irrelevant, avoided by both sides due to its complete lack of infrastructure. Lieutenant Hiroshi Nakamura, flying lead in a three-plane formation of Mitsubishi Zeros, expected to see nothing but white coral and palm trees. Maybe a few wrecked landing craft from an abandoned American probe. He'd circle once, photograph the lagoon, and return to base with confirmation that the Central Pacific defensive perimeter remained intact. Instead, he saw B's 24 Liberators. 4 of them. Parked on a runway that hadn't existed 5 days ago. His after-action report, recovered from Japanese naval archives after the war, captures the shock in dry military language: enemy air base observed at position previously surveyed as unsuitable for construction. Runway length estimated 5,000 feet, surface composition unknown, bearing multiple 4-engine bombers. Installation appears fully operational. Request immediate clarification on intelligence assessment. That clarification never came. Because there was no good answer. Across the Pacific Theater, the same scene repeated on island after island. Places the Japanese High Command had written off as geographical nullities suddenly sprouted airfields like weeds. Tarawa, Markin, Kwajalein, Eniwetok, Majuro. Atolls that Japanese doctrine classified as aviation incapable became American forward operating bases in less time than it took to ship reinforcements from Tokyo. The psychological impact was devastating. Japanese defensive strategy had relied on a simple assumption: vast ocean distances would slow American advances to a crawl, forcing them to pause for months between offensives to construct the massive supply infrastructure needed for air operations. But now American fighters were appearing hundreds of miles ahead of where they should have been logistically possible. The defensive perimeter wasn't collapsing, it was being leapfrogged entirely. Commander Mitsu Fukaida, the naval aviator who had led the attack on Pearl Harbor, wrote in his memoirs about the growing dread among Japanese pilots: "We began to fear not their planes, but their engineers." Every reef, every atoll, every sandbar became a potential threat. The ocean was no longer empty, it was a construction site. And the Americans weren't slowing down. They were accelerating. By late 1944, Seabee battalions had refined their techniques to the point of industrial efficiency. What took 72 hours at Tarawa took 48 at Tinian. What took a week at Kwajalein took 3 days at Saipan. The learning curve was vertical. Every island became a laboratory. Every problem became a lesson. Every coral reef became a runway. The Japanese continued to fight, but they were no longer fighting just American soldiers and sailors. They were fighting American logistics. American innovation. American refusal to accept that anything was impossible. And on that battlefield, they were losing catastrophically. The map on Admiral Chester Nimitz' wall told the story in red and blue pins. In January 1943, the blue pins, American-controlled airbases, clustered around Hawaii and a few hard-won footholds in the Solomon Islands. The red pins, Japanese bases, dominated everything west of Midway. The Pacific looked like a Japanese lake with a few American toes dipping in at the edges. By January 1945, the map had inverted. Blue pins covered the Central Pacific like a rash. Tarawa to Markin to Kwajalein to Eniwetok to Saipan to Tinian to Iwo Jima, a chain of coral and limestone stepping stones stretching directly toward Tokyo. Each pin represented not just territory, but reach. Every new airfield extended American bomber range by 300 miles. Every new strip brought another slice of Japanese-held territory within striking distance. And they kept appearing faster than Japanese intelligence could track them. The strategic implications were staggering. Traditional military doctrine said you advanced your lines by securing territory, building infrastructure, then projecting power forward from that infrastructure, a process measured in months. But the Seabees had collapsed that timeline to days. The American advance across the Pacific wasn't a march, it was a teleportation. Island fortresses that Japan had spent years fortifying suddenly found themselves cut off, surrounded by American air power that had materialized overnight from reefs that should have been unsurveillable. Nowhere was this more devastating than in the Marianas. When American forces seized Saipan and Tinian in summer 1944, Japanese planners knew they'd lost 2 islands. What they didn't realize was that they'd lost the war. Because within weeks, those coral atolls became bomber bases capable of reaching the Japanese mainland. B-29 superfortresses, massive strategic bombers that required runways over a mile long, began flying missions from strips that the Imperial Navy had surveyed and dismissed as unusable just 2 years earlier. The psychological reversal was complete. At Pearl Harbor, Japan had demonstrated the vulnerability of static bases to surprise air attack. Now, America had turned that lesson into a weapon system. But instead of relying on vulnerable aircraft carriers, they'd made the ocean floor itself into unsinkable flight decks. Coral fortresses that couldn't be torpedoed or sunk. Airfields that appeared faster than they could be bombed. For Japanese commanders, the nightmare wasn't the American attacks, it was the impossibility of predicting where they'd come from next. Every atoll became suspect. Every reef became a potential threat. The defensive perimeter didn't collapse gradually, it disintegrated, because there was no longer a line to defend. The front was everywhere and nowhere, appearing and disappearing with each Seabee battalion that turned another impossible location into a functioning air base. The Pacific War had become a war of construction speed. And America had brought the assembly line to the battlefield. Pearl Harbor began with fire falling from the sky. It ended with runways rising from the ocean floor. Somewhere between those 2 moments, the fundamental nature of warfare changed. Not in the famous battles, Midway, Guadalcanal, Iwo Jima, but in the anonymous hours between them, when men in grease-stained coveralls crushed coral into dust and transformed geology into grand strategy. History remembers the aircraft carriers and the Marines, the pilots and the submarines. It remembers Nimitz and MacArthur, Yamamoto and Halsey. But it often forgets the middle-aged construction workers who won the Pacific War with bulldozers and improvisation, who looked at a reef that every engineer said was impossible and decided to try anyway. Their legacy isn't preserved in monuments or battlefields. It's buried under the jungle overgrowth of 1,000 forgotten atolls, where crushed coral runways still lie beneath the vegetation, slowly returning to the ocean that birthed them. Walk across the islands of the Central Pacific today, and you can still find them, long strips of unnaturally flat ground cutting through the palm trees, harder than the surrounding soil, marked by nothing except the occasional rusted bulldozer blade half swallowed by sand. The Japanese weren't defeated by superior numbers or better technology. They were defeated by the terrifying American conviction that every problem could be solved if you threw enough creativity, machinery, and stubbornness at it. That impossibility was just a suggestion. That the laws of engineering were more like guidelines. That you could, in fact, put warplanes on coral. Chief Frank Hammer Fyans returned to Kansas after the war and went back to paving highways. He never spoke much about the Pacific, never wrote a memoir, never sought recognition. When he died in 1967, his obituary mentioned his service in the Navy construction battalions in a single sentence. It didn't mention that he'd personally supervised the construction of 11 airfields on reefs that weren't supposed to exist. But every time a B-29 took off from Tinian to bomb the Japanese mainland, it rolled down coral that men like Irons had crushed with their hands and compacted with their will. Every time American airpower leaped forward across the Pacific, it did so on foundations built by welders and dynamite men who'd learned their trade in Depression-era America and perfected it under fire. The war was decided by the men who built the runways, not just the men who flew from them. And the impossible became possible, one crushed coral reef at a time.